All right, lesson set 30, second part, mostly mechanical problems, the first half, and the second half of the video is mostly about graphing. And what we're trying to do is we're trying to get practice on a regular basis, 30 seconds here, 30 seconds there of different types of topics, so that we get a working knowledge and you're able to recall what you're doing here in your next level of study, because everything's built upon everything else. And so any problems here you can't do or don't understand are gonna cause trouble in future classes. So let's have a little practice. As I say, I'm not gonna talk about much here. The first 29 lesson sets, most everything that I see on the board, we've already done and talked about. So if this seems like problems that you can't do, then start with lesson set 1, figure out where you're at and get to practice. All right, 1/16 is 2 to the negative 4. I'm going to raise that to 2 minus x. 4 is 2 squared. I'm going to raise that to x plus 2. Now I'm going to use my rules of exponents. So I've got minus 8 plus 4x. Multiplication equals 2x plus 4. I'll take the 2x this way. I'll move the minus 8 that way. And it looks like x equals 6. Writing in E notation. Well, I got to change 1/2 into E notation, approximate E notation. So A of t can approximately be called 5 times e to the negative 0.7 raised to the t over 1,000. Rules of exponents apply again. So this is equal to 5e to the negative 0.7t divided by 1,000. And if I'm going to divide 0.7 by 1,000, I'm moving the decimal 3 places to the left from your elementary school math. So I've got negative 0.1237t. And that's approximately the same thing as that graph. And they don't diverge until, well, you move into more end behavior. All right, let's see. So let's do a sign chart first for this one. 10, I'll put a dot at 10. There's not going to be a sign change. X plus 3, negative 3, there will be a sign change, odd exponent. Negative 4, there won't. So not drawn to scale. I'll put a million in. A million gets me a positive, a positive, a positive. Is that true or false? I think it's false. Stays false. Becomes true, then it's false. So it looks like my answers are x is less than negative 3, greater than negative 4. It's important that you learn to graph these. So there's the 10. There's the, what was it, negative 3. There's the negative 4, not drawn to scale here. I'm not drawn to scale. All right, I know that a positive times a positive times a positive gives me a positive. So it looks like that, looks like that, looks like that. Where am I negative? Yeah, between 3 and 4. All these x values kick out things below the x-axis. Everything else is above or equal. So that looks good. Tangent of minus pi over 6, minus 30 degrees. I should be seeing that now and thinking, well, that's minus 30 degrees. So we'll draw a minus 30 degree triangle, but instead of hypotenuse being 1, we'll make it 2. And so those are the values. And so the tangent, negative 1 over root 3. 9 minus I squared is 81 minus double that product, 18i, plus I squared is negative 1, so 80 minus 18i. Right, oops, got a little cord here. Okay, right, x to the 6 minus y squared is a product. I see even exponents, so I'll do difference of 2 squares. X to the 3 plus y times x to the 3 minus y gets the job done. All right, we'll solve this, 32. Hopefully I'm pausing the video every time I hit a new problem. If you want to try them, pause the video. First stage of learning is following, so feel free just to watch me do them, and you're getting your practice for that for the day. All right, so 32 divided by 2, 16. So I got the ln of 16. Those are the 3 inverse operations, bang, 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 in the inverse order. Ln of 16, 16 is 2 to the 4, so e to the 0.7 to the 4 gives us an approximation of 2.8. Got to have a feel for size. 7 plus or minus 4i. What quadratic set to 0 gave me those answers? Well, if you do these for a while, you can just write your answer, minus 14x, 49 and 16, 65. So that's going to be our answer. Where did it come from? Moving the 7, plus minus 4i, squaring both sides, x squared minus 14x plus 49 equals 16i squared. What is 16i squared? It's equal to negative 16. So I bring the negative 16 over and check done. I see 5 root 4 root 10 minus 3 root 9 root 10. Sounds like a highway. Minus 2 root 10. I think I got a bunch of root 10s here. I've got 10 root 10 minus 9 root 10 minus 2 root 10. Did I get that right? 3 times 3 minus 9 root 10, yeah. And so that's 10 minus 11 minus 1 root 10. Let's move on. If you've done the earlier lesson sets, you can just write your answer. So 23 plus minus the square root of 17 over 2. Those are the roots, and they are imaginary. I almost forgot to say that, right? 0 is well below the minimum of 17. That is not intersecting here unless we have it flip over. And I squared gets that done. And when you square this x value and you take away 23 and you square that, you'll see why it works. Direct variation, y equals kx. We'll replace y and x now, y3, k, x2. So 3/2 is my new k. Constant of proportionality is now 3/2, so we'll replace k with 3/2. We'll get my eraser out of my pocket. It's not in my pocket, it's over here. And now I can replace y with 10. So 10 equals 3/2 x. Therefore, x is equal to 20 over 3. All right, moving right along, the y-intercept for this function. Yeah, I think we can see everything. I know that reflections of light sometimes cause problems on this board. So I'm going to replace x with 0. Anytime you want a y-intercept, that's what you do. You do the straight math. So I got minus 8 plus 16 plus 7 is what I think I see. Eyesight problem here. Looks like that's right. 23 minus 8, 13 and 2, 15. So 0 gets me 15. That should be the y-intercept of that. I got backup if I make a careless error here. Coordinates for, well, it's important that you understand what these graphs look like. So there's x cubed, and 5x squared actually does that. So we intersect at 0 and some small positive x value. Let's find it now. So we'll set them equal to each other. We'll factor. That's one way to isolate x's. We can isolate that factor. We can isolate that factor, and then we can see our answers of 0 and 5. Those are our answers for x. Certainly no need to talk about this. Set it to 0, x squared plus 2x minus 8 becomes x plus 4 times x minus 2. So it looks like x equals negative 4 and positive 2. Solve that equation. So I've got the function f of x. So f of something is equal to 2 times whatever you give me plus 1. That's what that's telling me to do. This calculation is telling me to take an input, double it, and add 1. Well, there's my input, 2a plus b. I'm going to double it and add 1, which is 4a plus 2b. 4a plus 2b, that is the question, plus 1. And now I'm going to do that again. So what am I going to do? I'm going to take my eraser, and I'm going to double that and add 1. That's the concept. So your final answer to this is written down here as 8a plus 4b plus 3. That's what that should be. All right, this is not the best problem to pick for showing the rules of logs, but this is equal to the ln of 64 minus the ln of 49 minus the ln of 10. Now, these are exponents that would go with the following calculations: 64, 49 times 10. That's what it would go to. The exponent you put on top of e to get 64. You would take that exponent and then subtract the exponents when you change these into e notation. And changing these into notation is finding the ln of 10 on your calculator, and that's going to be approximately 0.7 plus 1.6, it's going to be about 2.3 when you punch that into the calculator. And this is going to, so if I knew what the ln of 7 is, I would fool with this more, but I don't. So therefore, we're moving on. So I see a sine function, I see a positive sine function, I see one period, and I know that that distance right there, that dotted line distance is equal to 4 pi. How do I spot that? No, it's equal, yeah, it's equal to 4 pi. So I want x over 2 to equal 0. I'm going to get some space here. I want x over 2 to equal 0, and then I want x over 2 to equal 2 pi. All right, so that gives me 0, that gives me 4 pi, and that's the period. Now the shortcut to that is recognizing x over 2 is 1/2 times x, and taking that multiplier and dividing it into 2 pi. Okay, so hope you can see 4 pi. So this is 0, this is 4 pi. And that gets me a height of 11. That's the middle. I guess I'll show it over here just once. Height of 11. That's 5 up and 5 down. And so therefore, this is a maximum of 16. And this is a minimum value here at 6. Okay, that's enough practice for that. All right, so what do I see? I see a max. Well, I know the sine of pi over 2 is a max. So it would be very nice if I could get 1800 to act like pi over 2. Oh, you say I can? Yes, you're right. X minus 1800 plus pi over 2. Because if I unwrap this, I get a linear function. If I pull the string, it's linear. And so I can talk about where I am on the distance of that string by making a correlation. And I now know that I have half a revolution, which is pi units. And that takes 1800, very good year. I had good friends back then. 103 years have elapsed. And now I'm running into this one, so I apologize for that. But I can sneak it in. Sine function. Where the heck am I? I'm 38 to 50. So 38 to 50 is the midline, means I'm at 43, up 44, 44. Okay, so 44 is the midline here. So I'm going to tuck that at the end. That's the midline. I needed that. I'm going up and down 6. So I was able to get the equation here, not in the greatest way. And I apologize. I meant to write this as a cosine function because the cosine function maxes at 0. So I don't need that anymore. And that's the cosine function. Of course, I could have done it as a minus cosine function and as a minus sine function, and we could keep this going, but let's stop. All right, so we will put some ellipses into this graphing form here. We're just going to look at the graphing form right now of this ellipse. And we will do a few of them. Whether or not we put them on a test, I don't know. Got to stop the number of problems at some point. But if people understand everything that we're showing them in the next couple of weeks, we're going to put more problems there, but not grade them. So you got to find the center. The center of this is 7. Horizontal's not changing. Vertical's not changing. So 7, 0 is the center. And that's going up 3. That's going to the side 5. So the following equation is what you would have liked to have written. X minus 7 squared over 25 plus y squared over 9 equals 1. Okay, these are called axes. If the axes were the same, if that was a 9, then it'd be a circle. Right? All you got to do is multiply by 9 and you'd see the center. But we have different size axes here, major and minor, and it's the square root of those that give us that change. All right, so let's go do some sketching. Here's a linear function. I'll find 2 points and then I'll just sketch them. 1 gets me 3, change by 5, 6, change by 2, 5. I'll show this as AB. All right, so A, if that's 1, 1, 3, there's A right about there. And B is 6, 5, 6, 5. We'll call that B, connect them, and you're done. Cup shape up. This is the tangent to the point of inflection, so I should include that positive because that tells me I'm going up. This is the upside of that graph. So that's 0, 3. I'm almost done. I just need the vertex. Minus 20 divided by 4, minus 5. Plugging in minus 5 gets me minus 50 plus 30. And that's negative 47. which means I have the roots now because A is 2. And let's go back and do a similar problem. So if I wrote the graphing form, I'd have 2 times x plus 5 squared minus 47 equals 0. Now you might see why we don't need this, but you go ahead and solve that so that you could see the roots, which are right there and they're real, at x equals measuring from -5 plus or minus from the center of axis of symmetry. Got to go up 47 units, but I'm going to multiply by 2, so I'll do the inverse, and I'm going to square, so I'll do the inverse, and those are your roots. Many of you can do that in 5 seconds or less now. I'd like the whole class to be able to do that in 5 seconds or less. Of course, you got to spend more than 5 seconds looking at it. All right, so sketching. So there's our training wheels, -4, our training wheels of 5 units and 15. Those are our training wheels. So that should get me 1 if I pick the right answer. 15 minus 4, that should get me 11 if I pick the right input. What input do I want? I want 0 and 3. There, take the training wheels off. There's your exponential growth. There's your asymptotic behavior. Horizontal asymptotes for exponential functions, vertical for the logs, which are inverses, changing the x's and the y's. So x equals 2. If I could just find the right numbers, like 3, I could quickly write 5. And then if I pick 5, I think I could pick 8.5. 5 minus 2 is 3. What's the ln of 3? 1.1, so I just made a careless error. Nothing new there. 8.3. Okay, a little more time needed. Go back to the original, see what I wrote. I don't even remember, but that's the graph. Sinusoid. Pi. So I'm only looking at movement from max to min or min to max. Positive sine function. So I'm going to go from max to min. And that's going to take 17 years, starting in the year 1850. I had friends then too, very nice people. 1850, 3 pi over 2, it's muscle memory here. I didn't spot that until just now. So I'm going to go from min to min. I'm going to go from here because 3 pi over 2 is at the bottom of the circle, 270 degrees. Boom, -1 for a sine function. So 5 from 10, so this is 10. Going up to 15, going down to 5, and I'm going to be here at 1850 because I'm turning that year, if you look at this closely, you'll see a linear function. That's a linear function. And if I pull this just like a belt, if I take it off and I pull it, it's just a line. And so if you think of this as string and you pull the ends, then what you're doing is you're making years act like 1850, I want it to act like pi over 2, which is where the sine function maxes. And then 17 years later, at 1867, I want that to act like, I want a 3 pi over 2, excuse me. I did it again. If I add pi units to 3 pi over 2, I'm at really pi over 2, but in this case, I'm at 5 pi over 2, which is what you get when you add pi to 3 pi over 2. Okay, that's my belt. Here, it's in a different configuration, but when I straighten it out, this is a linear function. We're good at linear functions. We're real good at linear functions now. Nobody's making mistakes on linear functions. That's not the case when I used to teach it sequentially. Okay, and then I have students in Algebra 2 and Pre-Cal who would get that wrong on a final, and I'd scratch my head and I'd go, geez, I thought I covered it well. Well, what I didn't do was cover it often enough. That's what I found out, which is why I threw things out the window, and I'm doing it this way. All right, so where was I? I don't know where I am anymore. That function, I got to finish this off. So that gets me 5. 1850 gets me 5, and over here, one half a revolution, pi, top half, right? I went 180 degrees, halfway around before I repeat. 17 years gives me 1867. And that gives me 5 plus 10, 15. And that's that graph. All right, so I got to get some room here. Slowing down here, slowing down. All right, let's speed it back up. All right, first thing I see is I can't use the number 2. But I can reduce this. X plus 2, x minus 2, divided by x minus 2. F of x is really the function x plus 2, except for one little place that I cannot put on a graph. Hey, you'll hear teachers call it, well, I'm just gonna call it a point of discontinuity. All right. I'm not gonna use language that does not, for me, accurately describe what's going on. I think language is important. And I probably butcher it from time to time, but if I do, it's accidental. So I've got a linear graph here, x plus 2, going up at 1 to 1, except I can't have a place show up. It's certainly not asymptotic behavior. Whatever asymptotic behavior I have, I divide it out of the problem. So 2, I wonder what that height is. I don't know what that height is, but I wish I had something that could give me that height. Oh yeah, I do. It's 4. All right, so I'm ready to answer these questions. Where am I going? As x goes to infinity, it looks like I'm looking up. I think I could keep looking up forever. As x goes to 2, well, I know that goes to 4 now. Yeah. Table values, not what happens at 2. I mean, this point doesn't exist, but the table values certainly are gonna. What happens when I put in 1.999? I think that's an x value heading to 2. Sure looks like I'm close to 4. And what if I put in 2.01? Sure looks like the table values are heading to 4. And what happens when I put in 2? I get undefined. I'm sorry, I lost my train of thought because it's undefined here. So I can't do it. But the table values show me that this limit exists. I know where I'm headed. I may never get there, but I'm going to get real close. When am I less than 0? I can look at it now. -2 gets me 0. Sure looks like all these x values. Where are they? They sure look like they're less than -2 to me. Okay, let's go over and do another function. Let's graph x over x minus 5. So I'll get an xy axis for this one. I know it's undefined at 5. I can spot that immediately. I can spot, if I put a 0 in, I get 0. So it goes through the origin. Right? 0 over -5. So it goes through the origin. I can see that these numbers are 5 apart. Let's put some big numbers in here. Let's put about 1,005. Okay, then this would be 1,000. I wonder how many times 1,000 fits into 1,005. I would say it equals 1 and a little bit of a decimal after, which I'm not going to think about because I know that I'm close to 1 because I could add more zeros here. I could add more zeros here, right? And then it's even closer to 1. So let's write y equals 1. Let's write y equals 1 over here. All right, and now I know that I get sign changes. That's to the first power, that's to the first power. And I don't have any other x-intercepts. That's the only place I get an x-intercept. So it's got to do this. And we've done a bunch of those in the earlier lesson set, so I'm going to stop there. Make some space. Pausing the video each and every time you try to graph that, I see. Did you pause? I did. Cup shape down. What makes a 0? 5. If I put a 5 in there, I got 7. And if I put a 0 in, that's over here. I'll put a 0 in because I like to get through the y-axis in the right location. -30 plus 7, -23. And that slope on this side, we're doing piecewise, remember, it's going to have a slope of 6. And the one on this side, 10, -23, is going to have a slope of -6. And it goes through what? 5, 7. So there's your shortcut, which I'm taking from now on when we do piecewise. X less than 5. When it's greater than or equal to 5, we get x minus 5 plus 7. And let's just prove that it's 6. How do you get from -23 to 7? You go up 30. How do you get from 0 to 5? You go up 5. Sure looks like that's a 6-to-1 ratio to me. Done with that one. All right, we got 4 or 5 more problems to do. Running out of breath. Rolling Renee around. God almighty, I hope you don't have vertigo. All right. Graphing this sine function. All right, well, I see Mountain Valley again. I see 30. What's that period? That period is 2/5 is the multiplier times x, and I'm going to divide 2/5 into 2 pi. 10 pi divided by 2 is 5 pi. So from here to here, from that distance to that distance is 5 pi, which is approximately 5 times 3.14, which is 15.7. So from here to here is 15.7 units. I'm going to start at 0. I'm going to go up 7. I'm going to go down 7. And this is 5 pi. Gets me back to 30. Let's show 5 pi. 5 pi, what happens to the 5s? They cancel. 2 pi, the end of the revolution. The end of the revolution is a 0, right? On the circle like that, we get back to that spot. There's no height right in the middle. So we're going right back to 30. All right, space over here for this one. Oh, cubic, I better get a bunch of space. Thought I was doing a quadratic, do so many quadratics, a couple 100,000 at least. So we got, just looking at it, I think we're looking at something like that. We want the point of inflection. So we know when grandmother's, going from the gas pedal to the brake. Oh, no, she's braking and then the gas pedal. Yes. All right, so minus b over 3a. Positive 12 divided by 6, 2. So I now know that that x value is 2 without calculus. This comes from completing the cube, excuse me. Putting in a 2 is going to get me 16 there. So this is going to be 3 times that without looking, 3 times that. If it's not, I've made a mistake. Plus 10, plus 10, plus 20. And that's equal to twice that opposite. So minus 32. I don't even look at that. Double that and change the sign. Plus 20 gets me negative 12. I know that this is the tangent to the y-intercept. So 5x plus 10. That's the graph right there of 5x plus 10. Which means that my max has got to be an x value less than 0, because this is 0, 10. All right, so I got to be less than 0, and my x is equal to h plus or minus the square root of minus m over 3a. I'm not there yet because I got to find m. M is the rate of change right here. That's the rate of change. So I'm going to get that tangent, and then we can put it in graphing form. So if you get that multiplier, I need to remember c minus 3ah squared. I need to know that. The same way you need to know b squared minus 4ac in a different formula. Okay, so there's your formula. It's not hard to do. 5 minus 3, God, a is given. H you already found is 2 as well. So that's equal to 24, 5 minus 19. So I now know that the tangent right there, that tangent is minus 19 x minus 2 minus 12. Yeah, that's what I know. And I know the a term is 2. So this is actually it was a 2, wasn't it? This is actually the graphing form for that cubic. And when these are the different, when the rate of change at the point of inflection has a different sign, then we get local maxes and mins. If this had been a plus 19, the graph would have just been always increasing. But it's not plus 19. So therefore, now I can come up here and do that. H is 2. This is the minus side. Minus m is positive 19. And 3 times 2 is 6. Now that's close to the square root of 3, which is about 1.73. And what's 2 minus 1.73? That's a positive number. And if this is 0, that's a small positive. So it's right. And can you guess what this one's going to be for an x value of the min? If you said 2 plus the square root of 19 over 6, you would be right. Almost done. Instead of moving Rene the cart, we'll move Bill the board. Bill board, did you get it? Sorry. That was bad. I apologize. But gotta have a little fun. All right, x minus 2. So let's put it in factored form. Well, let's take the y-intercept since it's already given 2 15s. 2 15, 0 gets me 2 over 15. I know this is going to 0. Earlier videos talked about that. just briefly, this exponent is smaller than that, which means we're gonna get a number divided by x, and as x gets bigger and bigger and bigger and bigger and bigger, right? All I'm doing is looking at the major players here and reducing. X over x squared is 1 over x. So that's a number divided by x. So that's why it's going to 0. Now we can write x minus 2 over x minus 5 times x plus 3. All right, I'm not seeing any cancellation, so we have asymptotes at -3. Boy, that's an awkward rotator cuff moment. So x equals -3, and over here at x equals 5. That should be further over. Let's do justice to the cause. Get a little better scale. So there's 3. So there's, if that's 3, and that wasn't too bad, actually. I'm just too close to it, I guess. So that's x equals 5. I know that if I put a positive in, everything's positive, and I'm going to 0 over here from above, then it's got to do that. You can verify that by putting a 6 in. 6 gets me 9. 6 minus 2 gets me 4, 4/9. So really, I should do that first the next time. All right, so it's a little bit more like that, whereas 6 gets me 4/9. I might have done that too quickly. Hopefully not. It doesn't cross the x-axis except at x equals 2, and this is 5, so 2 is here. Okay, I can see what's going on now here, and I can verify that by plugging in x values. You go ahead and do that. Sign changes, positive to negative to positive to negative, so it's got to come in from below because everything's first power. So I get a sign change at 5, a sign change at -3, a sign change at 2. At 5, positive to negative. And then we go negative to positive, and that's at 2, right? 2, 0, right there. Okay, so I guess I talked about that enough. All right, how do I graph this one? Well, keep in mind that this is the same thing as 3 log base 1/5 x plus 4 plus 2. I feel like I should say that because these are exponents. Logs are values of exponents. If an exponent's negative, it means its base can be reciprocated. So it doesn't matter which one of these you look at. You're going to get a graph that is the inverse of decay, which looks like that. And so I'm going to plug in a number close to 4, but this is -4. All right, so I'm going to pick -3 and 4/5. -3 and 4/5. When I add 4, I get 1/5. And 1/5, what exponent gets me 1/5? 1. 3 plus 2 is 5. So -3/4 gets me 5. Now, I'm going to make this the number 1 because I don't care what the base is. You give me any base, as long as it's positive. It's got to be positive. It's defined to be positive. So base to the 0 gets me 1. So if I pick -3, I've created a 0. 0 times anything is 0. 2. So 3 gets me 2. Okay, and how far is it from 5 to 2? 3 units. Wonder if that's a coincidence. That's that graph. Now I need some space for the exponential. And again, just a reminder, if you want to try that, fine. If you want to just see me do it, that's fine too. You just got to get practice each day. Asymptote of 5. Training wheels, 12 and 3. And it's exponential growth. So I'm going to go up 3, and then I'm going to go up 12. 4-to-1 ratio. 3. Did I butcher that? So I'm going to go up 12 units. Yep, I get tired at the end. 12 times 3, 36. 3-to-1 ratio. Don't know where I was a moment ago. Maybe not in Kansas anymore. All right, so let's go here. Let's go here. Let's get rid of the training wheels. And let's draw the graph and pick our x's. I think I'm going to pick a 0, and I think I'm going to pick a 7. I think that's going to be easy to work with. 3 to the 0 is 1. 12 plus 5 is 17. And I think you can see why I put a 12 there. That's my initial jump. As long as I can make whatever this is, however complicated it is, 0 and 1, that's always going to happen. So that's what I do. So I'll put a 7 in, and if I do, I get 3 to the 1, 3 times 12, 36. There's your training wheels, plus 5, 41. A lot of you can do that very quickly now, which is nice to see. So that's that graph. I think I'm done. All right, let me upload this and hope I didn't make too many careless errors. I know I lost my concentration a few times, but it's good practice. And if you do these lesson sets, then I mean, the goal, we're on lesson set 30, that you can get a strong enough foundation to at least understand calculus. If you're studying it, you got a chance because your foundation is not going to let you down. All right, we aren't doing some problems that are in textbooks, but we're trying to get a working knowledge here. And so this is the attempt to make that happen. The only thing I haven't done is at the end of the videos, I do want to continue this process. Then I'll log off. I am going from a 2x2 square to a 3x3, and I'm filling in the area between those two. There we go. And I hopefully can figure out how to write what I'm doing, but I got a phone call, so bye. Stay safe and warm.